Okay students, good morning. So yesterday I have continued I have set the problem about laterally supported beams up to design bending strength and we have done the check for shear and check for deflection. So the remaining two checks will be done now. So already I said mainly for the column load we will have check for web buckling. So when the column tends to bend like this is called buckling. So why the buckling will be done means depend upon load. The buckling of column will be happen. If the beam bends for deflection, due to deflection it is called bending. If the column bends it is called buckling. So there is the difference between bending and buckling. So now we should do the check for web buckling. Okay, so for the yesterday video I am continuing the step 8. Okay, step 8, check for web buckling. So check for web buckling, I have told the formula for check for web buckling was F WB is equal to B into TW into FCD. So here B1 or B. So here B is nothing but bearing length, which is you should assume, and TW is the thickness of web, and this is the compressive strength. FCD is nothing but compressive strength. So here this value we will get from table 9C of page number 138 to 142, which is depends upon slenderness ratio, which is nothing but lambda, that is KL by R, which depends upon slenderness ratio. So okay, first we should assume B is equal to 100 mm. Okay, assume V1 is equal to 100 mm. Okay, so next next one. So here the formula will be like this: V1 into B1 plus H1 into TW into FCD. Here assuming the B1 value as 100 mm and the H1 is equal to H by 2. So height of the section was 550 by 2, that is 225 mm. Height of the section was 550 by 2, that is 275 mm. Okay, 275 mm. Next one, TW is 9.9 mm. So, but we don't know FCD, but FCD depends upon slenderness ratio KL by R. Slenderness ratio KL by R. So we should find out the slenderness ratio lambda is equal to KL by R, that is equal to, so directly we can write the formula 2.5 into D by TW. So in steps, by solving the KL by R, we will get the value of 2.5 into D by TW, which we can write as, so 2.5 into D 484, which I have written in properties, and TW 9.9, which we will get the value of 122.2. So remember this formula, which we want to solve lambda, that is 2.5 into D by TW. Okay, so 122.2. So we know the value of lambda as 122.2. Lambda as 122.2. But here from table C of page number 42, table C, so the lambda KL by R and Fy of 250, which is standard. The values were for 120 and 130. We will write 83.7 and 74.3. So the values of KL by R 120 and 130, but we want the value for KL by R is 122. So we want 122.2. So by interpolation, by interpolation. By interpolation, we will get the value of, therefore FCD is equal to, so I am writing interpolation 83.7 plus 74.3 minus 83.7 by 130 minus 120 into 130 minus 120 into 122.2 minus 120. This is the formula for interpolation. So we will get the value for 122.2 as 81.63 Newton per mm square. 81.63 Newton per mm square, which we will get the value for 120. So 81, so 83 and 74, in between the value is 81.63 Newton per mm square. So we will get the values for all. So substituting in FWB is equal to B1 as 100 plus H1 275 into TW 9.9 into FCD 81.63. By solving, we will get the value of F303 into 10 cube newtons, that is equal to 303 kilo newtons, which is greater than V. Hence, okay. So FWB web buckling value 303, which is greater than V. We have told the all design critical checks must be greater than shear force. So in case if the check was unsatisfied, the check for web buckling was unsatisfied, so here we should change the value of, if check was not okay, increase. If check was not okay, increase B1 value from 100 to 110, or increase the value of B1 value, If check fails, increase the value of B1 from 100 to 110, 120, 130 or anything. Okay, so if check for, this is the check for web buckling. So next one, check for web crippling. So next one, last step, check for web crippling. So this is also check for web crippling. The formula was FCW is equal to B1 plus N2 into TW F5 by gamma M0. So here N1, H1 or H2 also. So here say B1 is equal to 100 mm, N2 is equal, the formula for N2 will be changed. As 2.5 into TF plus R1. 2.5 into TF plus R1, that is 2.5 into TF, which is thickness of flange plus R1, radius of garage R1, as 82.5 mm. So by substituting the values in FCW, which we have 100 plus 82.5 into thickness of 9.9 into 250 by gamma 1.1. So we will get the value of FCW as as 410.6 into 10 cube newtons, that is 410.6 kilonewtons, which is greater than V. Therefore FCW greater than V. Hence okay. Same here also. If the condition fails, then increase value of B1, then increase the value of B1. If the condition fails, then increase the value of B1. Okay, so this is the check for web crippling. So this problem will come for 14 marks. Confirm. Gunshot problem. Laterally supported or laterally unsupported. So these 9 steps. Which I have told before, design steps and next design of laterally supported problem. So please follow the video and do the problem. If any doubts, ask me. Thank you.